Today, lesson 17a, solving one-step equations, day 1. Last year in the 6th grade, you talked about how to solve one-step equations, but you only did it with positive numbers. So the difference between what you did last year and what we're about to do, it's really the same process, but we now have integers that we have to deal with, so negative numbers in addition to positive numbers. So today, we're going to do the first half of one-step equations, and then tomorrow the second half, and then from there we go into more elaborate, more difficult equations to solve. But one of the things that we're also going to focus on today is correctly showing the steps. I've been teaching long enough to know that most 6th grade teachers don't make you write steps the appropriate way. So that's one of the things that we have to deal with. So today, solve one-step equations. We're also going to be writing equations from word phrases and stating the properties that we're actually using when we're solving equations. And then our typical why am I learning this? And in 8th grade science, you're going to be doing a lot of problems where you have to know how to solve equations. So let's go on here. When you were first presented with equation solving last year, I imagine one of the things you may have talked about was the idea of a balance. Right now, this is perfectly balanced. So if I were to subtract 3 from the left-hand side, what happens is this thing is no longer balanced. And we're trying to make sure that it is balanced. So the idea here is whatever you do on one side of an equation, you have to do the same exact thing on the other, because that means that the equation will still be balanced. Okay? And I think if you think about that for a second, that should make sense there. So whatever we do on one side, we have to do on the other side. Now, on the left-hand side, this is what I imagine. This is probably the way that most 6th grade teachers have you show your steps. We don't want to do it that way anymore. And the reason is because when we deal with negative numbers, we always deal with negative problems. In fact, if you were to go back and look at your homework from Friday and your homework from Thursday, and every other day that we've added and subtracted integers, they were always horizontal. In other words, straight across from one another. So while we can easily get an answer like the one on the left, we want to get away from that and do our work sideways. So what I'm saying is we want to make sure that we are doing our work sideways like this. And that's one of the things that we're going to work on today, making sure that we're doing the work the right way, because it leads to less mistakes when we do that. Okay? All right, so let's go on here. All right, vocabulary, inverse operations, and I'm sure that you've heard this before, even though you may not remember it from last year. These are operations that undo each other. Addition and subtraction are inverse operations. In other words, and I think that this is probably where you're supposed to write something in your notes, subtracting 7 and adding 7 are inverse operations. Here's another example that you need to add to your notes. Positive 9 and negative 9 are additive inverses. And as we just talked about, Miro asked that question if they were, and they are. Subtracting 7 and adding 7 are inverse operations. Positive 9 and negative 9 are additive inverses. It's really the same idea. And so the two operations that we're going to use today, or the two properties that we're going to use today, are this. Addition property of equality. This is when you add the same number to both sides of an equation. And if you add a number to one side, the addition property of equality says you also have to add it to the other side. And then we have the subtraction property of equality. This is whenever you subtract one number on one side, you also have to do the same thing on the other side. So the rules for transforming or solving equations, the idea is we want to get the variable by itself on one side of the equation. We always want to perform the same operation to both sides. And to undo an operation, we perform its inverse operation. And all of this stuff you should have talked about in the 6th grade. Addition and subtraction are inverses, and as we'll learn tomorrow, multiplication and division are inverses of each other. All right. Is this problem written in your notes? Yeah. Okay. So what we're trying to do here is we're trying to figure out what x could be to make a true statement. And I'm very aware that with these easy one-step problems that some of you can find out what x is in your head. But we have to learn how to solve these with the correct steps. And so what we're looking at here is we're looking at this operation on the left with the variable. And we have to think about how I can get rid of that plus 31. In other words, what we're trying to think of is this. What is the inverse operation to adding 31? Anybody have any idea what that is? Well, not subtracting negative 31. How about just subtracting 31? So that's exactly what we want to do there. We want to subtract 31 from both sides. So let's do that. Now all I've done here is I rewrote the problem and put a little bit of a space in between there. But we want to subtract 31 from both sides. Please make your problem look like that. Now, there are several checkpoints that will tell you whether you are doing the right thing or not. Okay? So listen very carefully. You are doing the right thing if these two are inverse operations or additive inverses of each other or opposites of each other, however you want to think about that. Look at what I circled. Are those two things opposites of each other? Yes or no? Yes. Yes, they are. So that means that we're doing the right thing. We're doing the thing that we need to do. Another way of thinking about it is this. Does that make 0? Yes. Yes. Additive inverses are numbers that have a sum of 0. So what that means is that we're actually using the additive inverse property. So I'm highlighting that just as a quick check. And in your mind, in your head, that's what you need to be checking for. Does that make 0? And of course it does. And that is the additive inverse property when we do that. So now, what happens is those two things, if we want to think of it this way, they cancel each other out. So can you cross those two out right there? Positive 31 and negative 31 make 0. In other words, they cancel each other out. So on the left-hand side, we are only left with one thing now, and that is x. And now we need to figure out what the answer to 10 minus 31 is. And we've done hundreds of problems like that, right? What's 10 minus 31? It's negative what? 21. It's negative 21. Add the opposite. We have 21 more negatives than positives. So x is negative 21. All right, so I want to clear up something right now because as I'm walking around and as I'm talking about this, most of you are writing down the right things. A couple of you are just writing negative 21. And that's it. That's not going to work. Because in about 2 or 3 days, we're going to be talking about more difficult equations where you're not going to be able to figure them out in your head. So how do I want you to write your answer? Like this. You have to state what the variable is. X equals negative 21. Just writing negative 21, not good enough. Okay? The other thing is this. Let me back off for a second. When I say that I want to see steps, that's what I mean. I want you to show me clearly what you did on both sides of the equation. And that's the thing that most 6th grade teachers don't make sure that 6th graders do. Yes? Can you just write the answer? The answer is no. Okay? Let me back up one more step. So let's pretend like this was a homework problem. Okay? Here's what you would need to do for your homework. Show me that you subtracted 31 from both sides, cross those out, and then write x equals whatever the answer is. So that's what I'm expecting to see. This is what I mean by work right here and answer. Work and answer. And as we're sentence framing this, the solution is x equals negative 21. All right. Let me get caught up here. Let's go to number 2. Y minus 8 equals negative 26. Could somebody please tell me what we need to do on both sides of the equation? And there's a quick check for that. Yes?
Have the opposite.
Well, you could, but you don't need to and when you're solving an equation. Yes?
Whatever numbers you have in front of like the variable, you have to, just like the balance, you have to put it on one side. Whatever you do on one side, you have to put it on the other.
Okay, but what do I want to do on both sides of the equation? What do I want to do? You're looking at this operation right here, and you're thinking about what is the opposite of that, or what's the additive inverse of that? Are we going to add 8, or are we going to subtract 8 from both sides? We're going to add 8. So this is what I mean by the step. You have to show me that you are adding 8 to both sides. Make sure that you write that down. You are adding 8 to both sides. The quick check, one more time, is right here. Are those two things opposites of each other? Are they, yes or no?
Yes.
They clearly are. In other words, they're additive inverses, which means that they make 0. So if that's the case, let's cross out that minus 8 plus 8. And now we know that y equals whatever negative 26 plus 8 is. And we're at a point where most of you can do that quickly in your head. So what is negative 26 plus 8?
Negative 18.
All right, so here's how we state our answer. The solution is y equals negative 18. We added 8 to both sides because that was the opposite or the inverse operation, and we got our solution of y equals negative 18. All right, let's try number 3. Everybody try number 3.
Going to, since it's positive 17 is going to be negative 17, we're going to go to the left, right.
Only, what do you mean right?
We're going to do negative 4 minus 17.
Okay, so let me ask you this. Could I just do this? Yes or no?
No.
What's missing from what I just did? Because this is a very common mistake. We have to show steps correctly.
You have to minus 17 on the other side.
You have to subtract 17 on the other side. And what you're doing here is you're making sure that those two things, you're either making sure they're opposite or you're making sure that they make 0. They mean the same thing. Opposite numbers, when you add them, have a sum of 0. Additive inverses have a sum of 0. So you're making sure that both of those numbers, plus 17 minus 17, that's 0. They're opposites, they're additive inverses. So we know that we're doing the right thing. So in this one, subtract 17 from both sides. We're making sure that we're using the inverse property, trying to create 0. And so the solution is w equals negative 21. All right. Now, let's take a look at number 4. Now I have the variable on the other side. There will be some of you who don't like the variable being on the right-hand side. So here's some advice. If you don't like the variable being over here, here's one thing that you could do. You could quickly rewrite that problem to look like this. You could do that. And for some of you, you're okay with the letter being on the other side. So let's go ahead and solve that equation. I'm going to do this with both things, or both ways there. The original problem and then the one where I put the variable part on the other side. So I'll do the original problem first. Obviously, I need to subtract 22 from both sides. And why do I need to do that? Because I'm trying to make sure that I'm using inverse operations right there. And so we know that d equals negative 7 after I add the opposite. 15 plus negative 22 is negative 7. So the solution is d equals negative 7. On the other one, you will see that it does not matter. I need to subtract 22. Subtract 22. These two things are opposites of each other. They're additive inverses. They have a sum of 0. However you want to think about that. And we get z equals, after I add the opposite, negative 7. The solution is D equals negative 7. Okay, I would like all of you now to do number 5 and number 6. Okay, let's take a look at both 5 and 6. Number 5, how many of you just left the equation like that? And how many of you rewrote the problem like we did in number 4? Okay, so I'll do it both ways. I'll do it by rewriting it and by just leaving it the way that it is, because it doesn't matter. If you do the right thing, you should get the same answer. So on the left-hand side, I need to subtract 18 from both sides. Why? Because now for the 6th or 7th time, I'm trying to make 0 there, or you can think of it as inverse operations, or you can think of it as opposite numbers. It doesn't matter. But remember, if you're going to subtract 18 on one side, you have to subtract 18 on the other. So we now have negative 34 minus 18, and I'm kind of squeezing it in there, but that would be negative 52 for C, and I didn't mean to write that there. So the solution is C equals negative 52. On the other side, subtract 18, and we get C equals negative 52 for the solution. Okay, number 6. As I complete that one. Now, this one is in here to make sure of one thing. Raise your hand if you can tell me what I have to do on both sides of the equation. Like in number 4, I had to subtract 22 from both sides. In number 5, I had to subtract 18 from both sides. What do I have to do in this one? Yes?
Add 9 to both sides.
Add 9 to both sides. Now, I saw a few of you subtracted negative 9. Is there anything wrong with that? No, because if you subtract negative 9, that's the same thing as adding 9. Think about it. Add the opposite. So in this one, we would add 9. Now, how do you know it's adding 9? Because, look, those two numbers have a sum of 0. Right, Ivan? Or they're opposites of each other. However you want to think about that. So the solution for number 6 is n equals 30. All right. Could I get everybody now to do number 7, 8, and 9? And this is kind of a summary of everything that we've talked about so far. I am going to give you about 30 more seconds to finish up all 3 of those. And then we will shoulder partner all 3 of them. Remember, the 1s take the odd-numbered problems. The 2s take the even-numbered problems. I want to hear several things. I want to hear what you did on both sides of the equation. But I also then want to hear the solution is whatever you got. Both things. What you did on both sides, like subtracted 22 from both sides. And then what you got for your solution. Go. All right, so as I said earlier, this is something that you did in the 6th grade, but you only dealt with positive numbers. So if it were any other way, we would have do both today and tomorrow in one day, but we're not going to do that because of the negative number situation. In number 7, here's what you should have done. You should have added 6 to both sides. Why add 6? Because those two things right there are opposites of each other. They're additive inverses of each other, however you want to look at that. And that would give us a solution of m equals 18. Everybody okay with that? All right. And you need to make sure that you show your steps. No steps, no credit. Let's go to number 8. Number 8 looks like this. We need to add 21 to both sides. I'm just double checking to make sure that those two things make 0. And so we're trying to figure out what W is. W is equal to negative 6. That is what the solution is. And number 9. We have negative 18 plus x is equal to negative 5. We would need to add 18 to both sides because we are trying to make 0 right there. The additive inverse property. And that would give us x equals positive 13 for the solution because we have 13 more positives than negatives. Everything okay so far?
Yeah.
All right, so let's go to words to turning things into equations. To save a little bit of time, I just want to work on the converting to an equation because as I was walking around, most of us are having no issue whatsoever in this idea of solving equations. Okay, so let's just work on words to the equation. We're not going to worry about solving it. So everybody take a look at that and write what you think the equation would be from that word phrase. I'll give you about 20 seconds. Daniel, what does your equation look like?
Negative 18, like, I put negative 18 equals to x minus 9.
Yeah, you just kind of follow the words, right? You basically read the exact sentence that was there. If I did ask you to solve it, we would have to subtract 9 from both sides because we want to make 0 right there. And negative 18 plus 9 is negative 9. So the solution is x equals negative 9, or negative 9 equals x. Let's take a look at number 11. Try that one, please. All right, Michael.
Okay, for number 11, I put b plus negative 3 equals 15.
Yeah. And one of the things you really should do is if you're dealing with negative numbers in a problem, you really should put parentheses around it just to separate it and let you know that that really is a negative number. But that's what it should look like. If I did ask you to solve it, we would have to add 3 to both sides, obviously, because we're trying to make 0 right there. And that gives us b equals 18. All right. We have 2 more problems here. But I think what we're going to do is, because we will come back to these kind of problems another time, and I think we're actually going to save them for that time. So we'll come back to those later. Quickly turn to your shoulder partner. What did you learn today? The ones are doing the talking today.